Hello there and welcome to the video that's going to go through the topic of composite functions. So let's first just recap the skills that we developed in the last two videos. So pause the video and have a go at these questions. Okay, so for question A, we're going to put 4 into the f function. So that's going to equal the square root of 2 plus 3 times 4. 3 times 4 is 12, plus 2 is 14, so it's the square root of 14, and that's going to be about 3.8-ish. Fg of 8, we put 8 into the g function first, leaving the f alone at the start. So put 8 into g, we get 8 plus 2 is 10, 10 divided by 5 is 2. And then we put 2 into the f function, so it's going to be the square root of 2 plus 3 times 2 is 6, so square root of 8, and whatever that is. And then when it says solve g of x equals 6, what you have to do is you have to grab your g function and then set it equal to 6. So x plus 2 divided by 5 equals 6. So this is an input, so this is an output, that's the number 6. 4 and 8 were inputs into the function, 6 is the output, it's the answer, where we want to find the input, which is x. So times by 5 to get rid of the divide by 5, which is 30, and take away 2, which will give you 28. So 28 is the answer for part C. And let's have a go at these two more difficult questions. Pause the video and have a go at these two. Okay, so gf of 13, you put 13 into the f function first. So g of 3 times 13, that's 39. Take away 1, that's 38. And then you put 38 into the g function, so that's going to be 38 divided by 2, which is 19. Lovely. And then part B is solve f plus g equals 20. So grab your f function, write that underneath. Grab your g function, write that underneath, and then it equals 20. So one thing we could do first is just times everything by 2, and that will give us 6x minus 2, and then if you've got a half x and you double it, you get x equals 40. So on both sides of the equation here, we've just timed all the individual elements by 2. 6 plus x is 7x, and then take away the 2 on, so add the 2 onto the other side, you get 42, and then divide by 7 and you get 6, so 6 is the answer to part B. Okay, little activity before we get started on the composite functions questions. Just pause the video and no one's going to see your answers to these, so give it a go of what you think the answers to all 6 of these questions are going to be. Work through them one by one. Pause the video and have your best go at these 6 questions. Okay, so well done for having a go. In the first one, we're going to put 6 into the f function. And what you do when you put 6 into the f function, you do 2 times 6 and then add 5. So 2 times 6 is 12, add 5, you get 17. Lovely. So there's a nice, easy numerical answer for this one. Now when you put a, now the 6 is now an a, so we're going to put a into the f function. So when you put a into the f function, you're going to have to replace x with the letter a in this case, because it tells you to use an input value of a. So what you're going to get is you're going to get 2 times a plus 5, and that's as good as you can do, really. You can't turn this into a numerical answer. This is more of an algebraic answer. So that's the best you can do. That's the answer for part B. If you didn't know how to do part B and you gave up on the rest of them, then I'll pause the video and have a go at the remainder before I go through them. So now we'll put t into the f function. So we're going to replace x with the letter t this time. So 2t plus 5 is the answer to that one. When we do part D, we're going to be replacing x with the square root of x this time. So it's going to be 2 times the square root of x, the input value, so 2 root x, add 5. That's the answer to part D. Next one is x squared, so I'm going to be replacing in the function x with x squared this time. My input is x squared, so it's going to be 2x squared, add 5. And the new function I'm going to put in now is x plus 3, so where there's an x in my function, I'm going to now write x plus 3. So it's going to be 2 brackets x plus 3 plus 5. So my input here was x up here, but in my question the input was x plus 3. So I had to write in x plus 3. And it's always a good idea to expand your brackets and simplify. So it'd be 2x plus 11. So there we are, we're putting weird algebraic things into our function now, rather than just numbers. Okay, so putting algebra into functions is a really important skill for composite functions, so we'll do a couple more. Pause the video and have a go at these 6 questions. Okay, so for the first one, it's putting 8 into the function. Nice and easy, we've done this before. So that would be 24 minus 7, that makes it 17. Putting the letter b into the function now, that will make it 3b minus 7. Putting the letter t into the function, that will make it 3t minus 7. Putting the value x plus 2 into the function, now that's going to make it 3 times x plus 2 minus 7. And it'd probably be a good idea to tidy up this. It would be expand the brackets, 3x plus 6 minus 7. And to tidy this up even further, it would be 3x minus 1. For part E, it's putting square root of x into the function. So that'll make it 3 times the square root of x minus 7 on the side. And for the final question, it's putting x divided by 5 into the function. So that'll make it 3x divided by 5 minus 7. And we'll do one more set of questions related to this. So it's really important you can put algebra into a function. So let's have a go at this question. Pause the video and give these 6 questions a go. Okay, so for part A, it's just a bog standard simple putting a number into a function question. So it's going to be the square root of 13 minus 9. 13 minus 9 is 4, square root of 4 is 2. Now let's put a into the function. So we're going to be replacing x with the letter a. So it's going to be a minus 9 square rooted. Putting w into the function now, that's going to make it w minus 9 all square rooted. Putting 3x plus 8 into the function, that's going to make it 3x plus 8 minus 9. And we can simplify the inside of the square root here. That'll make it 3x minus 1 square rooted. Putting x squared inside the square root, that'll make it square root of x squared minus 9. And you're thinking, could we simplify this? Well, no, we can't. When you've got a subtract in the middle of 2 squared things, you can't simplify a square root. And putting x divided by 2 into the function, that will make it x divided by 2 minus 9. So all of these functions, all of these pieces of algebra that we have inside the bracket have all slotted in to the x position in all of these substitutions. You can see a has appeared here, w has appeared here, 3x plus 8 has appeared here, x squared has appeared here, and x divided by 2 has appeared here. So where you've got an x in your function, that's where these pieces of algebra are going to be substituted into. So let's have a look at composite functions then. So a composite function is something that's made up of several parts, and a function is a composite function, a function that's made up of 2 or more different functions. So we've seen before, if we put a letter or a number into one function and then put that number into a second function, we have put the answer into a second function to get 49. Now what we're going to be creating here is a function that can take 3 put it into like a super function that does both things and spurts out the number 49. So it's going to do this function and then this function to give you an answer. So 3 will go into our function. It's going to be a more complicated function than these two separately, and will give you 49 as an answer. So we're creating kind of super functions here. So here's how we're going to do it, and we need to bring in that skill of putting algebra into functions. Okay, so here we're going to create the composite function g(f) of x. So one way that we need to remember to think about this is we need to remember that it's the f function that we're going to do first. One way of visualizing this is to put brackets around the f function, or you could also remember that it's the function that's closest to the x that we're going to do first. So we're going to look at f here. And the f function is this one here, x plus 4. So what I'm now going to do is I'm now going to replace f of x with x plus 4 inside the bracket here. And now is where I need to use that skill of putting algebra into a function. So I need to now put x plus 4 into the g function. So where x is where x plus 4 is now going to appear. So it's now going to be the answer of x plus 4 all squared. This f function went into the g function, and then I put that f function into the g function where x was. So the answer is x plus 4 all squared. Okay. And this turns 3 into the number 49. We can see that doing that. If we were to put 3 into this function here, 3 plus 4 is 7. 7 squared is 49. So we've put 3 in to a single function, and we've got 49 out of it. And these two functions here have had to have been combined to make this one here, where we do the f1 first in the brackets, and we do the square outside the brackets. Let's have a go at another question then. So it's g(f) of x again. So just put some brackets around the f of x just to highlight that it's the f function we're doing first. Then get rid of the f and write instead what f is equal to, and that's x plus 7. And now is where we need to use that skill of putting algebra into a function, and we're going to put x plus 7 into the g function. So where x appears, we're going to write x plus 7. So it's 5 brackets x plus 7. So the answer is 5 brackets x plus 7. Let's have a go at another one. So in this question here, we need to create the composite function g(f) of x. So put those brackets around the f function, get rid of the f function and pop in x minus 3, because that's what f of x is. F of x is the x minus 3 function, so I've just replaced f of x with what f of x is, x minus 3. And now we need to put x minus 3 into the function g, so where x is, x minus 3 will now appear. But what happens if we reverse the order of these letters, f and g? This time f is first and g is second. Well, what this means is that the g function needs to be done first. So I'm going to replace g of x with x squared. So x squared is the function going into this one. And now is where I need to use that skill of putting algebra into a function, x squared into the f function, and it's going to be x squared minus 3. So x squared went into the f function, x squared went into the f function where x was. So the answer here is f of g is equal to x squared minus 3. And notice that there is a difference between this answer and this answer. So it's really important that you remember that you do the function that's nearest to the brackets first, because otherwise if you do it the other way around, you will get the answer wrong. Okay, let's have a go at these two questions here then. Pause the video and give these two a go. Okay, so how would I do this using pen and paper? So I'd first write out g of f of x equals. I'd leave the g function alone because I'm going to do the f function first. I'm going to write x over 3 because that's what the f function is. Then I'm going to put this algebra into the g function. So where I have x here, I'm going to write x divided by 3. X divided by 3. So my answer here, putting x divided by 3 into the g function, is x divided by 3 plus 4. So the answer here, gf of x equals x divided by 3 plus 4. And that will do the f function first and the g function second to whatever letter or number I put in as x. And doing it the other way round now, fg of x, well, I'll leave the f1 alone at the start and I'll do the g1 first because that's nearest the x letter. So it's going to be x plus 4 into the brackets. And now I'm going to put x plus 4 as algebra into the f function. So in it goes, replace it with the letter x, and it's going to be x plus 4 divided by 3. And that's the answer to part B. fg of x equals x plus 4 divided by 3. And notice there is a difference between this answer and this answer. So it really does matter that you get the letters in the correct order. Let's have a go at another one. Pause the video and have a go at these two questions. Okay, so gf of x. So gf of x I'll write down. Then I'm going to write down g, and I'm going to do the f function first, because f is nearest to the brackets, and f is the function square root of x. Then I'm going to replace x with the square root of x in the g function. I'm going to put this algebra into the g function. So it's going to be 7 minus the square root of x. And there we are, that's the answer. Then I'll move on to doing fg of x. So I'll leave the f at the front. Then I'll write out the g function, and the g function was 7 minus x. Then I'll put this algebra into the f function. So where x appears in the f function, I'll write this algebra. So it's going to be the square root of 7 minus x. And there we are, that's the answer to part B. Let's have a go at another question. So we're building up lots of practice here. Pause the video and have a go at this one. Okay, so gf of x, so gf of x, I'll put the g at the start, and then I'll write out the f function. And the f function here is x plus 8 divided by 3. The next thing I'll do is I'll put this algebra into the g function. So where x appears in the g function, I'll write this thing here. So it's going to be, in brackets, x plus 8 over 3, all of it squared. And that's the answer to part A. Moving on to part B, fg of x. I'll leave the f alone at the front and I'll write out the g function, x squared. And then I'll put this algebra into the f function. This is the f function here, so where x is, I'll write x squared. So it's going to be x squared plus 8 divided by 3. And there we are, that's the answer to part B. Let's have a go at another one, building up that expertise and confidence. Pause the video and have a go at this question. Okay, so this one's a little bit of a different one. It's f of x, where you have to do the function twice. It's like putting a number into a function machine and then putting the answer back into the same function machine. So I'll leave the first f alone at the front, and I'll put in the second f rather, 2x minus 7. And now I'm going to put this algebra into the f function. Now this is the f function, and this is what I need to put in. So it's going to be 2 then where x appears, I'm going to write this expression here, 2x minus 7. And then I'm going to continue the rest of the f function to minus 7. I'll tidy this up by expanding the brackets and then simplify. 4x minus 21 is the final answer. Always, when you can, expand the brackets and simplify final answers. Let's move on to this question here then. Pause the video and have a go at this one. Okay, so for fg of x, I'll write out fg of x equals, I'll leave the f1 alone at the front, and I'll write out the g function. That's 4x minus 5. Then I'm going to put this piece of algebra into the f function. So 4x minus 5 into the f function. Where x appears, I'll write this expression here, 4x minus 5, and then I'll continue the rest of the f function, plus 8 divided by 3. And then I'll simplify the numerator, 4x plus 3 divided by 3, and that will be my final answer. Okay, let's move on to the next question. Pause the video and have a go at this one. Okay, so for fg of x, I'll write out fg of x, and I'll leave the f alone at the front, and then for the g function, it will be 3x minus 5. Then I'll put this algebra into the f function, so it's going to be 8 divided by 3x minus 5, because that's where x is in the f function. So that's the answer to this question. And for the second part, gf of x equals, I'll leave the g function alone at the front, then with the f function I'll write that into the bracket, and then I'll substitute this algebra, 8 divided by x, into the g function. So I'll start writing out the g function, and then where x appears I'll write 8 minus x. So 8 divided by x. Now this one's a little bit more difficult because in the g function there's 2 places to put f. So pause the video and have a go at this complicated question. Okay, so it's going to be fg of x as the first one, so I'll leave the f alone at the front, and I'll then write out the g function, so that's x squared minus x. And then I'll put this piece of algebra into the f function. Now this is the only place where x is going to go, so it's going to be x squared minus x minus 3 to finish off the rest of the function. So there we are, that's the answer to part A. But part B is a little bit more tricky. Gf of x equals, I'll leave the g function alone at the front, and I'll write out the f function, and that's x minus 3. And now I'm going to put this algebra into the g function. Now where x appears in the g function, I need to write x minus 3 instead. So it's going to be x minus 3 squared, because I need to put it in that x, but also take away x minus 3 being put into this x, so x minus 3. And there we are, just for the benefit of making this a short question, I'll leave my answer here. You could expand the brackets and simplify as well. Right then, so it's now your turn to complete the questions from the worksheet in the link in the description of the video. So pause the video and take some time to have a go at those set of questions. We'll go through the answers to the questions in the video, in the worksheet now. So let's pause the video and have a go at this one. Okay, so the answer to part A is fg of x, and let's write down our working line. So it's going to be f of the g function, which is the square root of x. And then I'm going to put this algebra into the f function. So it's going to be the square root of x plus 9. Moving on to part B, gf of x. First of all, I do the f function because the f function is nearest the brackets. So the f function is x plus 9. And then I'm going to put this algebra into the g function. So the g function is this one here, so it's going to be the square root of x plus 9. Where x appears in the g function, I'm going to write x plus 9. And then part C is a question that we've done some of before, but I'm going to show you a different way of doing it now. If I've got fg of 5, what I could do is I could take it in turns. I could put 5 into g and then that answer into f, or I could just put it straight into part A, because if you can see it goes fg of x, fg of 5. If I just replace x with the number 5 that I've got in my question for part C, then I'll get the answer. So it's going to be the square root of 5 plus 9, which is the answer. And you could probably work that out on the calculator, probably be something like 11.2, 11.3-ish. Let's move on to question 2 then. Pause the video and have a go at this set of questions. Okay, so for part A, it's going to be f of g of x. So I'll put the f at the front and then I'll write out the g function. That's x divided by 4. And then I'll put this algebra into the f function. So where x appears, I'm going to write this expression here. So 2 brackets x divided by 4 minus 3. I could simplify this to x divided by 2 minus 3, because 2 divided by 4 is a half, so it's a half x. Moving on to part B, gf of x. I'll leave the g alone at the front and I'll write out the f function, which is 2x minus 3. Then I'll put this piece of algebra into the g function. So where x is in the g function, I'll write this thing here. So it's going to be 2x minus 3, all divided by 4. And for part C, gf of 2, I'm going to use part B as my template, and I'm just going to replace x with the number 2. So it's going to be 4 minus 3 divided by 4, which will make it a quarter, or 0.25. Let's move on to question 3 then. Pause the video and have a go at these 3 questions. Okay, so for part A, it's fg of x. So I'll leave the f alone and I'll write out the g function, which is the square root of x. And then I'll put this algebra into the f function. So that's going to be the square root of x over 5. Wherever x appeared in the f function, I'm going to write this thing here. Part B, gf of x equals, so I'll write out g and then I'll write out the f function inside the brackets. That's going to be x divided by 5. And then I'll put this algebra into the f function. So that's going to be the square root of x divided by 5. So 5 will be inside this square root. 5 wasn't inside that square root. So I'll now do part C, which is fg of 9. Now I'm going to use part A as my template for this. I'm going to put x, I'm going to replace x with 9 because the function structure is the same. So it's going to be the square root of 9 divided by 5. Square root of 9 is 3. 3 divided by 5 is the answer, or 0.6 as a decimal. Let's move on to question 4 then. Pause the video and have a go at these 3 questions. Okay, so for fg of x, I'm going to write out fg of x equals, I'm going to leave the f alone at the front, then I'm going to write out the g function, which is x squared, and then I'm going to put this algebra into the f function. So it's going to be 7 minus x, but I'm going to write x squared here because I'm putting x squared into the function. Part B, gf of x, so I'm going to write out g, and then in brackets, the f function, which was 7 minus x. So I'm now going to put this algebra into the g function, and where x appears, I'm going to write 7 minus x. So it's going to be 7 minus x squared. And for part C, it's GF of 4. And I think here I'm going to use part B as my template and just replace x with the number 4. So that's going to make it 7 minus 4 squared. That's going to be 3 squared, which is 9. Let's move on to question 5. Pause the video and have a go at this question. Okay, so for part A, it's going to be f of g of x. G of x was 4 plus x. And then I'm going to put 4 plus x into the f function. So where x appears, I'm going to put 4 plus x. That's going to make it 10 over 4 plus x. For part B, it's gf of x. So that's going to be g of the f function, which is 10 divided by x. And then I'm going to put 10 divided by x into the g function. So that's going to make it 4 plus. Now where x appears, I'm going to write 10 over x like this. And there we are. That's the answer to part B. And then part C, it's gf of 16. Now what I'm going to do here is I'm going to use part A as my template and just replace x with the number 16. So it's going to be 10 divided by 4 plus 16, which is 10 divided by 20, which is a half, 0.5. Let's now move on to question 6. Hopefully you're getting familiar at this. Question 6, pause the video and have a go at this question. Okay, so for part A, fg of x, so it's going to be f of the g function. The g function was x plus 3. And I'm now going to put x plus 3 as algebra into the f function. So in both places where x appears, I'm going to write x plus 3. So it's going to be the square root of x plus 3 minus brackets x plus 3. And it's minus all of this function here. So if I were to expand the brackets, I'd have to leave the x plus 3 in the square root, and it'd be minus x minus 3. Moving on to part B, so this thing at the back, here's the final answer. Gf of x. So the g function, I'm going to put in the f function, that is the square root of x minus x. And then I'm going to put this algebra into the g function. So where x appears, I'm going to write what's in the bracket here. So it's going to be the square root of x minus x, and then add on 3 to finish the g function. And for part C, gf of 16, so I'm going to use probably part B here as my template and just replace x with the number 16. So it's going to be the square root of 16, take away 16, add 3. So let's work this out. That'll be 4 minus 16, add the 3. So that'll make it 7, take away 16, which will be minus 9. Let's now move on to question 7. Pause the video and have a go at this question. Okay, so let's have a go at these 3 questions then. So for part A, it's going to be f of the g function. So the g function here is x squared. And then I'm going to put this algebra, x squared, into the f function. So where x appears in the f function, I'm going to write this algebra. So it's going to be x squared plus 4 over x squared. X squared had to appear in 2 positions, up here and down here. Moving on to part B, it's going to be gf of x. So write out g and then the f function. The f function here is x plus 4 divided by x. And then I'm going to put this algebra into the g function. The g function just squares things. So it's going to be x plus 4 divided by x, and then all squared. And then for part C, it's going to be gf of 2. Now here I think I'll use b as my template and just replace x with the number 2. So it's going to be 2 plus 4 divided by 2 squared. That would be 6 divided by 2 is 3. 3 squared, that's 9. Lovely. Let's move on to question 8. Pause the video and have a go at this one. Okay, so getting started with the first bit, fg of x. So I'll leave the f alone and I'll write out the g function, which is x plus 8. X plus 8, I'm now going to replace x plus 8 into the f function. So where x is in the f function, I'm going to write x plus 8. So the first bit, there's an x, so that needs me to write x plus 8. And then finishing off the f function, it'd be plus sine of x, and we need to write there x plus 8 again. So that's the answer to part A. Moving on to part B is now going to be gf of x. So it's going to be g of the f function. The f function is x plus sine x. And then I need to put this algebra into the f function, into the g function. The g function only has one x, so I'll just rewrite out this algebra where x is. So it's going to be x plus sine x. And then I'll finish off the g function plus 8. And then moving on to part C, fg of 52. So I'll use part A as my template, just replacing x with the number 52. And I'll get 52 plus 8 plus sine of 52 plus 8, that's 60. So my answer is going to be 60. And then we all know sine 60 is root 3 over 2. And there we are, that's the answer to part C. Now let's move on to some more complicated ones here where we have to solve an equation. We're going to link this into the composite functions we've just learnt and video 2 where we were doing a little bit of problem solving. So pause the video and give this question a go. So the first thing we need to do is create the f of g function. So f of g of x equals, let's make it first, so it's going to be f of the g function, so that would be 5x plus 1. And then I'm going to put this algebra into the f function. 5x plus 1 goes in as x into the f function, so it's going to be 2, lots of x, but I'm going to replace x with 5x plus 1. Minus 9. And now I can finish off writing that this thing equals 13. Now I've got to solve this and work out what x is. Find the value of x. So I need to work out what x is. First thing I think I'll do is add 9 to both sides. So I'll write out this expression here, and I'll add 9 to the other side, and I'll get 22. Then I'll halve both sides to cancel out this 2 at the front, so 5x plus 1 equals 11. Then I'll take away 1 from both sides, and I'll get 10. Then I'll divide by 5, and I will get 2. There we are. 2 is the value that when I put it in as x, I'll get 13 out again. Let's just check it if you want to. fg of 2. Put 2 into the g function first, and you will get 5 times 2 is 11. Sorry, 5 times 2 is 10, plus 1 is 11. Then put 11 into the f function, and you'll get 22 minus 9. 22 minus 9 is 13. Hey, 13 is the output value when the input here was 2. So let's move on to the next series of questions which are very similar to this kind of question. Pause the video and have a go at question 10 here. So let's make up the function first. Gf of x equals g of the f function. The f function here is 3 minus x. Then I'll put this algebra into the g function. So it's going to be 4, and then where x appears, I'm going to write 3 minus x. So 3 minus x plus 5. And now I can write equals 5. So I've got an equation here. So now I think what I'll do with this thing here is take away the 5 from both sides. So I'll end up with 4 brackets 3 minus x equals 5 minus 5 is 0. Divide both sides by 4, and 0 divided by 4, well, it's still 0. Add the x onto the other side, and you get x equals 3. And there we are, that's the answer to question 10. Let's move on to question 11 then. Pause the video and have a go at this question. Okay, so the first thing to do is to make the function f of x. So let's leave the f alone at the front there and do the first function. The first function is 9 minus 2x. And then I'm going to put this piece of algebra into the f function again. So where x appears in the f function, I'm going to write this thing here, 9 minus 2x. And that equals 1. Because that's what I've told my answer is. And now I've got an equation. But what I'm going to do is I'm going to simplify what's on the left-hand side first. I'm going to write 9 minus 18 from expanding the brackets, and then plus 4x from expanding the brackets again. So all I've done on the left-hand side is just expanded the brackets. Now I'm just going to simplify the left-hand side, so that would be minus 9 plus 4x equals 1. I'm then going to add 9 onto the other side to make it 10, and then divide by 4 to make it 2.5. So 2.5 is my answer there. Let's move on to question 12 then. Pause the video and have a go at this question, question 12. Okay, so first thing I need to do is make this function here. So g(f) of x equals g of the f function, which is x divided by 3. Then I'm going to put this algebra into the g function, so it's going to be 2 lots of x divided by 3 plus 9. And this thing equals 13. So I now have my equation here. The first thing I'll do with my equation is take away this 9 at the start. So take away 9 from both sides and you'll be left with 4. Then I'll halve both sides to get 2. And then I'll times both sides by 3 to get x as 6. And there we are, 6 is the answer to this equation. Then move on to question 13. Pause the video and have a go at this question. Okay, so first thing I need to do is I need to make the function. So f(g) of x equals, I'll leave the f alone at the start. Then I'll put in the g function, which is 3x plus 5. And then I'll put this 3x plus 5 into the f function. So 3x plus 5 goes in as x, so it's going to be the square root of 3x plus 5. And this thing equals 7, because I'm told that it equals 7. So now I have my equation. First thing I think I'll do is I'll square both sides to get rid of this big square root. So 3x plus 5 equals 7 squared, which is 49. Take away the 5 from both sides and you'll be left with 44. And then 44 divided by 3, well, that's going to be a very difficult calculation. It's going to be, so 30 will make it 10, 42 will make it 14, 14.67 or 14.6 recurring. And that's the answer for x. And let's move on to the final question then. Pause the video and have a go at question 14, final question from the worksheet. Okay, so f(g) of x equals x. So let's first make the f(g) function. So f of the g function is 7 minus 2x. And then I'm going to do the f function to it. So take this algebra and do the f function. So it's going to be 7 minus 2x divided by 5. And this thing apparently equals x. So now here is my equation. First thing I think I'll do is I'll times by 5 onto the other side. I'll then add 2x onto the other side. So x equals 1. Lovely, there we are. And that's all the questions we're going to go through in this composite function video. It's quite a difficult topic, composite functions. Students always struggle on it. It used to be even in the A-level syllabus. That's how difficult it was. So If you didn't understand anything, have a look back at the video, maybe re-watch it a couple of times, pause different parts and have a go at questions again, even if you've already done them, because you're definitely going to be increasing your ability to do the questions if you redo questions. And well, yeah, thanks very much for watching.